So for today, did you remember that a radian was where both of the radiuses are equal, of course, but you open up the angle enough so that the curve, the arc, is also equal. So like, let's say this is 8 inches long and this is 8 inches long, and then this is 8 inches long, and then this is your angle, and that angle would be 1 radian. And remember, it's close to 60 degrees, but a little less. Why a little less? Because then when you actually put 3 of them together, you get close to going to 180, but you don't get it until you get 3.14 of them. 1, 2, 3.14 of them, and then that's why pi is 180. All right, so moving on. You're supposed to be able to do these too, but we already practiced this just a minute ago, so we're not going to practice that again. Next, we're going to move to, if you wanted to find coterminal angles, we need to know what co and terminal mean. Okay, co means that you share the same. Okay, so like if you cohabitate with somebody, you, for instance, cohabitate with your whole family. You live with your family. Well, you probably do, I guess. Can't know that for sure. But if you live in the house with your dad, then you and your dad are cohabitating. Co means in the same, all right, or at the same. Now, how about terminal? Terminal, you might think means, like, you probably heard it in the context of terminal cancer, meaning that's going to be the end. But terminal means technically terminate means stop. Okay, so if you terminate something, it's you stop that. Okay, so if I'm opening an angle up and I start here and I keep opening it up until I stop right there, then that is where it terminated. And that means that spot is where it stopped, and this spot was where it started. And so then my angle was 120, and it started here and it terminated there. And so then that is a way to get to this spot right here, is you swing from 0 this way. But some of you probably have thought, well, you could swing the other way and get there as well. And you could. And that would open a much bigger angle, more than 180. In fact, if you think about it, it would be, let me think, 90 plus 90 would be 180. Plus, if that one's 120, couldn't I just take 360 and subtract 120? And that would make it, let me see, 240. Yeah, so this would be 240 degrees. But to say it's 240 degree angle would miss the fact that you went backwards. So it's called negative 240. So 120 and negative 240 are called coterminal. They stop in the same spot. All right, so let's see if you really got that. I'm going to give you another one. It's right here. And it's in degrees, 135 degrees. Figure out something else that stops in the same spot. Your starting spot's always there at 0. Megan Ishii, what do you think it is?
I'm trying to figure out if I'm supposed to use the 180 over pi.
Oh, I don't need to use radians yet. I'm still trying to do this in degrees, and then I'll morph it into radians later.
Okay, so if we're looking the other direction, then it would be 360 minus 135.
Very nice. I don't know if you can do that in your head quick. So 225. But we can't just say 225. And we can't just say 225 degrees. There it is, negative 225. Okay, and now we can also say them in radians. All right, so remember on the radian deal, 180 was pi. And if I was going to do this in radians, the first thing I would think is, okay, how about this spot? what would that be? And then I do a bunch of those 45-degree angles. That would be 45, but it would also be pi over 4. If you haven't memorized these yet, I'm going to make you a nice little list right now that would be really handy to know as we're doing this unit. Pi goes with 180. If you don't know that by now, I haven't apparently said it enough times. Or you haven't been working on your homework enough. So pi is 180. Pi over 2 is like 180 over 2, which is 90. You should know pi over 2 is 90. Boom, just right away. Most people know those two. How about pi over 3? Say it if you know it.
60.
60. Very nice. And couldn't I just think of pi as 180? 180 divided by 3 is 60. Yes, you could. How about pi over 4? 45 is correct. How about pi over 5? We never use it. It's a thing, but we pretty much never use it. Okay, it's like the name Ishmael. It's pretty rare, unless you're reading the book Moby Dick, in which case, yeah, you might find it there. Back to pi over 5, it doesn't exist. I mean, it does, but we don't use it ever. So how about pi over 6? That is probably the most common one, because you can do a lot of things can divide up nicely into pi over 6s, like a whole bunch of pi over 6s. And that's like 180 over 6, which would be 30. All right, we really don't use pi over 7, pi over 8, pi over 9, pi over 10, pi over 11, pi over 12. But these we use all the time. And of course, sometimes we use the bigger ones, like 5 pi over 6 or that kind of stuff. But if you start with just pi over 3, and you can say, oh, I know what that looks like. And then you can go 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. Like if you can get the multiples of it, you're in good shape. So what I'm doing right now is this one, I'll circle it in red, pi over 4, which is like 45 degrees. So this is 1 pi over 4. The next stop would be 2 pi over 4. The next stop would be 3 pi over 4. That is 3 pi over 4. But what about if you do it negative? Then it's negative. I'm making stops at every 45. And I'm going to count it up because honestly, this is the way I do it. And I'm a teacher of this stuff. I don't try to memorize them all. I go, okay, so this is negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 4 pi over 4, which makes sense because, 4 pi over 4 is like 1 pi. So negative 4 pi over 4, so negative 5 pi over 4. There's 4 things that are all coterminal to each other. They all stop in the same spot. 135, negative 225, 3 pi over 4, and negative 5 pi over 4. All right. So, what do you think? You feel like you get this? Let's see if you do. That spot right there. Give me 4 names for it. In degrees, you can get 2 different degree answers. One's positive, one's negative. And you can get 2 different radian ones. Hint. I'd start out with a 45-degree angle and then go, oh, that's pi over something. And then I'd count it up and see how far do I have to go to get to that red line. Give me 4 names for that. I'll pause for a second. Give you a chance to process that. So if I wanted to, I could get answers that go past the spot like I did with the blue arrows. And I counted it up. I was already at 5 pi over 4. And then I went 6, 7, 8, 9, 10, 11. Oh, I think it's actually 12 pi over 4. I just realized. Does anybody agree and thought it was 12 pi over 4? Put your virtual hand up if you were thinking that. Okay, maybe I'm wrong. So I'm going to double check this. I was here at 5 pi over 4, right here, and nobody seemed to argue. So I'm going to go 6 pi over 4, 7, 8, 9, 10, 11, 12. No, it is 13 pi over 4. I just counted wrong just now. Okay, sorry. 13 pi over 4 was correct. Okay.
Can't you just add 8?
Yes, you could absolutely add 8 pi over 4. I am trying to get you used to this whole counting it up thing. But yes, there's always shortcuts, and this area of math has got tons of, well, you could just do this. And I'm trying to make sure that I kind of show you the easiest way. All right, so now we got to get into our last thing for today, which is how to change rotational motion into linear motion. It feels kind of awkward to throw this in today, but didn't you see I just went around and around? Okay, so that's kind of like going around in a circular motion is kind of like that. So let me get to that part. Already talked about this. We talked about that. And we've done that. All right, so this is angular velocity is another way to say it. Okay, if you were a science teacher, you might say it that way. So if I want to look at this tire and I zoom in on this tire, imagine that on the back of this tire, there is a little piece of tape right here. Okay, so there's some tape right there. Do you get, if you go really fast, the tape's going to go around, around, around. It's going to go really fast, around, round, round, round. Okay, and by measuring how fast it's going, you could tell how fast this bike is going, this motocross bike. All right, so it's going around in a circle, but you could say how many miles per hour the guy is going by talking about how many rotations per minute his tire is doing. All right, so I personally am going to use some different numbers than this because I think it'll be easier if I give you different numbers. So let's do imagine a bike tire. And let's say that we have a radius of 8 inches. This is like a little kid's trike tire. All right. And there's going to be a little piece of tape right here. And we're going to count how many times it goes around. And we're going to say that it does 5 rotations per 1 second. 5 rotations in 1 second. That's going really fast. It would be hard to keep track of that, but let's say we did. Maybe we recorded it on our iPad and then played it back and we're able to track it down to like, yeah, that was 5 rotations in 1 second. Then could you change that to miles per hour? This is sometimes called dimensional analysis in science class. You multiply by a bunch of facts. Now, one fact I know is that 1 rotation, I could have put it on top, but I didn't. I put it on the bottom on purpose because I want it to cancel. Do you get, if I have 1 on the top and 1 on the bottom, they will cancel? 1 rotation is the same exact thing as a circumference, right? And so let's say this was 8 inches. So then 1 circumference would be, I'm going to write it down so you remember this formula. Circumference is pi times the diameter, right? And the diameter is 16 inches, so this is 16 pi. Our circumference is 16 pi inches. So 1 rotation is 16 pi inches. That was the hardest part right there. And all it really was realizing a rotation is a circumference, and the circumference, you had to know the formula for that. So this hardest part, the rest of it, pretty easy. Because you'll know they're facts. Like how many inches is there in a whatever? Well, what are we trying to get it to? It's good to know your goal. What's my goal? My goal is to get it into miles per hour. And is inches part of miles? No. So I got to get it out of inches and into the next thing. Wouldn't it be logical to use 12 inches in 1 foot? That's a fact. 1 foot over 12 inches, it's like a 1. That's why we can do this. We can keep multiplying by these things because they're all equal to 1. Because it's the same on the top and the bottom. Why do I use inches? Because then the inches are gone and now the foot is left on top. And my new unit has feet on top and seconds on the bottom. Am I done? No. And let me tell you this, I'm telling you now, and you're going to say later, I don't remember how many feet are in a mile. Memorize it. We don't give it to you, and we expect you to know it. So I'll tell you now, and you just need to memorize it by test day. There's 5,280 feet in 1 mile. You are going to have to know that one. Just memorize it. It's good to know. We have a weird system in the United States. If we had metric system, you'd know it was like either 10, 100, or 1,000 because their system is cool like that. And for us, you just have to memorize a few things, and this is one of them. 5,280. All right, now why did I do that? Because feet will cancel. And now I have miles per second. Can I be done? No, because that's not miles per hour. So I have to do one more thing. This little seconds here has to get canceled. So I'm going to put seconds on top, and I got to do a fact about seconds that I know that helps me get closer to miles per hour. Ooh, I know this one. 60 seconds in 1 minute. Now, some of you are going to be like, it would be even smarter, Mr. Server, if you said how many seconds are in an hour. You're right. 3,600 seconds in 1 hour. That's smart. Now my seconds cancel with the other seconds, and I have miles on top and hours on the bottom. Cool. You just got to multiply all these numbers across the top and all these numbers across the bottom. And that is, how many of you have seen this before? Put your virtual hand up if you've seen this kind of problem before. Interesting. Yeah, it's usually the tale of two cities. I got about half of you guys are going to be like, this is easy. We did this in science. And the other half, they're going to be like, what is he doing? I've never seen this before. Okay, so it all depends on which science class you've taken, whether this is going to feel easy or not. All right, so I'm going to do one more like this. And I'm going to call it good. And if you're not good at this, you'll have to go back and watch this video over again or get extra practice, because for some kids, they don't even need this extra practice problem. Let's say it's a saw blade. The saw has little teeth on it, and it is going to spin really fast and go, let's say, 2,000 RPMs. Have you ever thought about what RPM means? Put your virtual hand up if you think you know what RPM stands for. Avi, what do you think it is?
Rotations per minute.
You are correct. So, I need to know one more piece of info. I need to know how long that is. So I'm going to say it's 6 inches. That's how big the saw blade is, 6-inch radius. Now, if I were to put a little mark on this, it doesn't matter where I put the mark. I'd keep track of it. I could see how many times it goes around in 1 minute. And we're saying it's going to do 2,000 rotations per minute. So you start by writing out 2,000, and a big mistake is to say RPMs. You want to actually separate them. Rotations per 1 minute. That's how you start. Then you got to multiply by a bunch of things. All right, figure it out. I'm going to be quiet for a minute, give you a chance to solve this one. And by the way, I want miles per hour at the end. So one kid asked a good clarifying question, I'll put it in the video here, is do we want this answer as a decimal, or do we want to just leave it? I actually want you to just leave it as a big multiply problem. I'm mainly trying to tell if you know what things to multiply by to get it to change all the way from rotations per minute to miles per hour. So don't even have to multiply it all out. Leave pi in it. So how I would start is I would go rotations. Let's get that out of there first. One rotation is one circumference. Now, I don't want to like write just one circumference right there. I want to actually figure out what one circumference would be. A circumference is pi times the diameter, and the diameter is 12, so this would be 12 pi. And I gotta say what it is. Units are what this is all about. 12 pi inches. That was the hardest part. After that, you're off to the races with things like 12 inches, 1 foot. And I like to cancel them as I go to make sure that I know what I still have left. Inches, inches. Okay, now I have feet per minute. All right, and now my minutes, I can change by getting minutes up on the top. And I want to get closer to hours, right? 60 minutes is 1 hour. So yay, I got my minutes canceled. And now I've got what per what? Feet per hour. And 5,280 feet. Hopefully you didn't have to look it up. Cancels. And then we've got what? Let me think. What is 5,000? Oh, 1 mile. And now I cancel off foot, feet, and I see what my units are. I'll highlight them in blue. I have miles on the top, and I have hours on the bottom. Miles per hour, yay. I know you all can multiply. So you'd multiply across the top, multiply across the bottom, and then you divide them, and then you could get an answer. So put your virtual hand up if you are going to like that question on a test. You're going to feel like this is a happy place. Okay. Maybe by the end you'll say, dang, I like those a lot better than the other ones. So I think honestly these are not too bad. This should be, from my experience, most kids get this right on the test. So all right, so let's make sure that we learned everything you're supposed to learn. It was about coterminal angles, and here's a word, and rotation problems like this one. A yo-yo, which is 2.25 inches in diameter, spins at a rate of, how fast is it spinning in miles per hour? And round your, don't even bother to get the decimal places. Just get it set up, and let's make it a lot faster. Let's change this into feet per, let me think, feet per second. That'll be a lot easier than miles per hour. Figure out how fast it's going in feet per second. Don't have to even multiply it out, just get all the factors written out. One rotation is a circumference, and the circumference is pi times the diameter, and the diameter is 2.25, so 2.25 pi inches. And I got rotations out of there. Now I'm at inches per minute, and I wanted feet per second, so I got to get inches to feet, so I'll put inches here. 12 inches, 1 foot. Now my inches can cancel. Now I got feet per minute. Now I just got to get minutes out of there, so I put minutes here on the top to cancel them. And it's 1 minute is 60 seconds. Minutes are gone. Final answer, highlighting in blue, is feet per second. How many of you guys had that one right? Put your virtual hands up if you did. Okay, so we now have time to work on this homework. You would start here, and I'm going to make a small change to what I've been doing. I'm going to add a Dropbox. I found out this is what my colleagues have been doing all along when they aren't taking it as a formal part of the grade, but they want to see, is the kid doing any homework? So I'm going to put up the Dropbox. And again, I can't make you, well, I never could, but I'm not even putting it in the grade. But for things like conferences, when the parents are saying, so is my kid doing any homework? Right now, I couldn't prove if you are or aren't. So I'm going to ask that you Dropbox what you do with no judgment on my part until we see the test scores of whether or not you did too much or too little or whatever. Okay, but you should be doing some homework every night. So I'm just asking you to Dropbox it. And we'll have it there if we need to look back and say, well, were they doing it? Were they doing it on time? Were they doing any of it? Were they only doing like one problem? And yeah, for some of you that have decided, hey, this is an awesome new world where I'm not doing anything, I'm convinced that's not good for you. And at least we'll know whether you're not doing anything. Okay, so I'm putting Dropboxes up, and you Dropbox your stuff, but I'm not going to be going through and giving it a grade. It's just there to prove either, yeah, you've been doing homework, or nope, you haven't. And then when the grades are good or bad, we'll be able to judge whether you're doing enough homework. Okay, so keep doing your homework, folks. Any other last questions? Okay, so that's it for the video for today.